Okay, you guys, this is section 4.1, and the name of the section is classifying triangles. I hope you remember some of this stuff from middle school or from elementary. And all you have to know here is how to name a triangle. So triangles have special characteristics, okay? The first one, here we have, you can classify triangles by their angle measure, so please underline that. Because I could ask you, what's the name of that triangle? Well, it depends. If it's by their angle measures, you can call it equiangular. What is equiangular? Well, equiangular is when all the angles are equal. They're congruent. So the angle could be equiangular, and it could also be acute. Acute is when you have all the angles less than 90 because they're acute. So if the angles are less than 90, they're considered acute angles. And if the three of them are acute angles, then the triangle is considered an acute triangle. The second triangle, right triangle, and the characteristic here, the special one is that one angle, it's a right angle. Can you have two right angles in a triangle? No, it's not possible. Why is that? That's right. If you have two right angles, there's no way you can have a third angle because just on those two 90 is 180. So you cannot have more than 180 in a triangle. We're doing Euclidean geometry, which means that the sum of the three angles is 180. If you were to do non-Euclidean, like on the spheres, if you have a triangle, see there you can have more than 180, but not in Euclidean. This is Euclidean, okay? The third triangle, it's called an obtuse triangle, and the special characteristic is that one of the angles is more than 90, which is in this case 104. So that's an obtuse triangle. Could you have two angles or obtuse angles in an obtuse triangle? And the answer is no, there's no way. The same idea about the right triangle, okay? So you could say that the angle is equiangular and acute. Could you say that is equiangular and right? No, right? Because you cannot have all the angles the same. You cannot have more than one right angle. Can you have equiangular and obtuse? No, there's no way you have obtuse more than 90 and then this more than 90 and this is more than 90. No, no way, okay? So the only one that could be equiangular is if it's acute. 60, 60, 60 is considered an acute and equiangular. So that's a special one. Second concept, you can use also angle measures to classify the triangle MJL, MJL, and that would be at, this is what you can use angle measures to classify the triangle at right, which is this, not the right angle, but at the right, which is this one. The angle JLM and the angle JLK form a linear pair, so they're supplementary. So JLM and JLK are supplementary, which means that the sum of those two angles should be what? 180. So if one angle is 120, what should be the other angle on the other side? It would be 60, and this is the equation to get that angle, okay? Then let's practice. What do you think is number one? It says classify by the angle measure. So what is that? Right. It's a right triangle. Okay, so right triangle. And I'm just going to put a little triangle symbol there. Okay. Okay, so what about number two? It's obtuse, much better. And number three, it's acute because all the angles are less than 90. Acute triangle. Then we have number four. It says use a figure to classify its triangle and its angle measures. So the triangle DFG, I'm going to highlight it with the DF. So here I'm talking about this triangle here. So what type of triangle is that? It's a right. Then let me use another color. DEF. So it's DEG, DEG. So it's this one here. So what type of triangle is that? It's acute. See, even though we don't have that missing angle, we can find that missing angle by saying, well, the sum of 54 plus 68, 12 carry 1, 122. So that angle would be 180 minus 122, and that's 58. So that angle is 58. And so if you look at the three angles, they're acute angles, and therefore it's an acute triangle. Okay. Number 3. Let me use a different color. EFG. E, F, and G. Okay, well, I'm missing one angle, which is this angle here. Who knows what the measurement of that angle is? How do I get that angle? I can add 32, 36, and subtract from 180, but also from the other idea, isn't it that those two are forming a linear pair? Right? Okay, so I can just subtract the angle given, which is 68, from 180, and that would be 112. Thank you, Jasmine. So it's 112. So since that is 112, then I can conclude that since that's an obtuse angle, then the triangle is an obtuse triangle. I was going to put acute. Obtuse triangle. There you go. Okay. Moving on to the next page. So on the right side, we have classified triangles. We can also classify the triangles by the side lengths. Okay, so I could ask you, what is this type of triangle based on the angle measures or by the side lengths? So by the side lengths, you could have an equilateral triangle. The equilateral triangle is when you have all sides congruent. Okay, equal sides, equilateral. Lateral means sides, equal, the same. So sides are all the same. Isosceles triangle. This one, please make sure that you pay attention to this. The definition says that it has at least two sides. So by at least, that means that what? It could be more, right? So an isosceles triangle usually is the one that has the two tick marks, right? But which other one is going to be isosceles also? The equilateral. That is right. See, the equilateral, it's also an isosceles because it has at least two sides congruent.
So like on the test,
Uh-huh.
say if you were to give us a triangle like the
Equilateral.
we were to put isosceles, would that be kind of wrong?
No, it's not kind of wrong. What you're going to have to do is, I'm going to give you the question that says, what's the best name for this triangle? And the best name would be equilateral. And that's where I can get you. I was like, the best one is equilateral. So glad that you asked that question, Ceci. The equilateral, it has, that is right. That is right.
Isosceles triangle, it has to be at least two.
At least two.
So if it had three, it would be equilateral.
That's right.
Two, it would be isosceles.
That's right. So my question to that would be, what are the possible names that this triangle could have?
So it would be both.
And at that point, you're going to say equilateral, isosceles, and based on the angles, it would be, and I'll give you measurements of angles, acute equiangular, if it's 60, 60, 60. So then you're going to give me all the four names. Okay? Good questions. And then the third type is a scaling triangle, which has no sides congruent. And then we have an algebra problem. It says QR. It says you can use triangle classification to find the side lengths of the triangles. Okay, so, and here we have the tick marks, which means that they're all the same. So they're giving me these two to be the same with tick marks. I can let them equal to each other, find my x, then come back, plug it in. 5 times 4 is 20, so each one of the sides is going to be 20. Okay, now let's move on to the bottom part. Number 7. It says classify the triangle by its side lengths. Okay, so I have EGF. E, G, and F. So what's the name of that triangle? Isosceles. Isosceles triangle. Second one, DEF. So it's DEF. How about that one? It seems to be scaling, right? What I'm going to do is I'm going to have this. I have two tick marks. Since one of them has 13, this one is also 13. I have two tick marks. That's a 20. So the other one that has two tick marks is also 20. So if you were doubting, okay, what is that supposed to be? It was 13, 14, 20, which is all different. And you're right, it's in a scaling. And then the last one. It's isosceles? Okay, so DFG is the whole thing right here. And that is right, since that's 20, this 20. And then, I don't see the numbers, 13 and 14 together, that would be 27. So it's a 27, 27, I'm sorry, 20, 20, 27. You're right, it's an isosceles. That's it. Questions about how to classify by the side lengths? So far, so good. Okay, now let's do the algebra problems over here. I have tick marks all around. So if I want to classify that, it says find the side lengths of each triangle. So side lengths, I need to know how much those are. So here I can say that 5x minus 1 equals 4x plus 1. Then I just saw 4x. What do you move first here? The x, so let's subtract 4x over to the other side. That would be x minus 1 equals 1. And then we add 1 to both sides. X equals 2. Now here they want the side lengths, which means that go back and substitute that. So when I substitute, I put x equal to 2, that would be 4 times 2 plus 1, that is 9. So this is 9, 9, and that would be 9. So the side lengths, they're all 9, right? So all the sides, measures.
So then if all sides equal
Is
9.
9. Equilateral, right. If they were to, if they asked me to classify, then I would just say it's an equilateral triangle, yes. Could that be an isosceles? Yes, it could also be classified as an isosceles, but the best name is equilateral. Number 11. Let's do the same thing here. Let me get a different color. So what's going to be my equation in 11? Can you do what?
Like, do you have to do all three, or do you can just do two? Just two.
That's a good point. I can only use what here?
Just two.
It's only the ones that are equal.
Oh,
Yeah, so I just use the ones that are equal. So what's going to be my equation?
X plus 4
3x plus 4,
equals
x plus 6. Yeah, so I cannot use the other one because that one is not the same as the other two. Okay, now solve for x. 3x minus 1x is 2x. Right? Then we subtract. What do we subtract? 4 from 6.
It's 2.
And that would be 2 divided by 2. So x is 1. So the side lengths would be, let's see, 3 times 1 is 3 plus 4. 7. So then the side length would be 7, 7, and, okay, let me put it over here. 2 times 1 is 2 plus 2 is 4. So those are the measurements, 7, 7, and 4.
Oh, so you would put the x now into